Okay, hope everybody's doing well. Today we're going to talk about section 7.2, which is going to focus on the law of sines and solving triangles that aren't necessarily right triangles. So we're not going to be able to use SOHCAHTOA today. We're going to have to use what's called the law of sines. And before we get there, I want to just make a couple of notes. First of all, law of sines is used for non-right triangles, and it is used for the following three situations of given information: angle, angle, side, angle, and side, side, angle. So I've drawn three triangles here just to illustrate what those are. And so angle, angle, side means that you are given two consecutive angles in the triangle and then the following side after it. Angle, side, angle means that you're given two angles consecutively and then the side that's in between those two angles. And then side, side angle means you're given two consecutive sides and then the angle that follows it as you go around the triangle. So those are the three situations in which we use law of sines. Now, the law of sines formula is right here. A over sine A equals B over sine B, C over sine C, where the capital letters are your angles and the lowercase letters are your sides. And so if we had a triangle here and we called our angles capital A, capital B, and capital C, the sides always correspond with the angles. So side A is going to be across from angle A, as you can see there. Side B is going to be across from angle B, and side C is going to be across from angle C. And we call these ratios. Okay, so when you hear me say the word ratio, the B ratio, the A ratio, what I'm talking about is A over sine A. That would be the A ratio. Or C over sine C. That would be the C ratio, etc., etc., etc. Okay, so we're going to start with example 1. We're going to solve the triangle, which means we're going to find all of the missing information, all of the missing sides, and missing angles. Okay, so we're given BC and little c. And so if we think about on our triangle here, we are given this angle B, we are given this angle C, and we are given side C right here. And so you can see that I'm given angle here, and side here. So this is angle, angle, side, which means we are going to use the law of sines, which you could probably guess since this is the law of sines notes, and we haven't talked about any other laws just yet. But in section 7.3, we'll talk about the law of cosines. Okay, so in the law of sines, I have to be given one of the three ratios, either the A, the B, or the C ratio. And I see here that I am given the C ratio because I have angle C and I have side C. So I'm going to set up, first step, that C ratio, which is 5 over the sine of 80. And I'm going to set it equal to my B ratio because I'm given angle B. So my B ratio is going to be side B divided by sine of angle B. And then I'm going to solve that equation for little b. So anytime we have a fraction equal to a fraction, we're going to cross multiply. And so this is going to be b sine of 80 is equal to 5 times the sine of 45. And to get b by itself, I'm going to divide both sides by sine of 80. And you need to make sure that your calculator is in degree mode. So right now, make sure your calculator is in degree mode. Punch this into the calculator, and I'm going to round everything today to the nearest tenth. And so that's going to give me b is equal to 3.6. Okay, the second thing I'm going to have to do to continue solving for this is we are going to find the missing angle, and so that would be angle capital A that we're missing. And since I know that a triangle, the angles all have to add up to 180, that means I'm going to subtract the two angles that I have from 180, and so that's going to give me A is equal to, when I punch that into the calculator, 55 degrees. Okay, the last thing is we are missing side little a, and so we're going to again use our given ratio, which again was the C ratio, since we had the angle and the side for letter C, and we're going to set that equal to our A ratio now in order to solve for little a. So once again, just like in step 1, I'm going to have 5 over the sine of 80. This time I'm going to set equal to the the A ratio, which is A over sine of capital A, which I just found in step 2. And then I'm going to cross multiply and divide. So A sine of 80 is equal to 5 sine of 55. And then dividing by sine of 80 on both sides is going to give me A is equal to, and punching that into the calculator, rounding to the nearest tenth, is going to give you 4.2. Okay, so that'll do it for example 1, angle, angle, side, using our given ratios. Example 2, this time we are given capital C, capital B, and little a. So if I were to use one of my triangles again, I'm going to try my best to draw another triangle. That'll be good enough. This is going to be A, B, and C, and we are given angle B here, angle C here, and side A here. And so as you can see, that is angle, side, angle, which means that we are going to use the law of sines. Okay, so we have to be given a ratio in order to use the law of sines. And notice that in my given information here, I am not technically given the same letter twice. We have C, we have B, we have A, but if I have both of these angles, that means I can find the third angle. So the first thing I'm going to have to do here is I'm going to have to find that third angle, capital A, by subtracting the two given angles from 180 degrees. And so that is going to give me 64 degrees for capital A. And now when you combine that with little a, I have the A ratio. So now the last two things are to find side B and side C, and we're going to use our given ratio, the A ratio, which is going to be 11 over the sine of 64. I'm sorry, let me erase that 63 there. 11 over the sine of 64 is going to equal to, and it really wouldn't matter which one you did first here. I'm just going to do the B ratio since, you know, alphabetical order and everything. So the B ratio would be B divided by sine of capital B, which is 53. Cross multiply and divide. So B sine of 64 is going to equal to 11 sine of 63. And then divide both sides by sine of 64. So I'll try to fit that in here just real quick. And punching that into the calculator, rounding to the nearest tenth, is going to give you, I'm going to do it over here where I have some room, B is equal to 9.8. And then step 3 is to find side C, so little c. And again, we're going to use our given ratio of 11 divided by sine of 64. And this time set it equal to the C ratio, which is going to say C divided by the sine of capital C, which is 63. Okay, cross multiply and divide that, and what you're going to end up with is C is equal to 10.9. Okay, example 3 and example 4 are exactly the same as example 1 and example 2, so I want to give you a chance to try these examples on your own, and I'm going to write up the answers here, and then you can check your answers with that. If you have any questions on example 3 or example 4, then please feel free to let me know, but go ahead and pause the video here for just a second and try those two examples, and then when you unpause, you will see me writing the answers on the screen. Okay, so there are your answers for example 3. And for example 4, you're going to have capital C is equal to 140 degrees, little a is equal to 3.2, and little b is also equal to 3.2. Okay, example 5 is going to be talking about SSA. So sometimes whenever we use the law of sines and SSA is the given information, there may be one triangle, there may be two triangles, or it's possible that there may not be any triangles. And I'm going to hopefully carefully explain how to determine when each one is the case through example 5. And so example 5a, we have A is 10, B is 9, and capital A is 50. And so just notice here real quick that if I have A, B, and C, then what I'm given is side A, which is here, side B, which is here, and capital A, which is here. And so you can see that that is indeed side-side angle, which means we are going to use the law of sines, and we're going to have to figure out how many triangles there actually are. Okay, so for the first thing that we're going to do is we're going to try to find angle capital B. So notice that my given ratio is the A ratio here, so that would be 10 over the sine of 50, and we're going to set that equal to the B ratio in order to hopefully find angle capital B. So that'll be 9 divided by the sine of capital B. We're going to cross multiply and divide, so 10 times the sine of B, I'm going to do the cross multiplication first so you can clearly see what happens here, is equal to 9 sine of 50, and then I have to divide both sides by 10 in order to get sine of B by itself. And so sine of capital B is going to equal to 9 times the sine of 10, times the sine of 50. Let me erase that and put what I meant to write. So 9 sine of 50 divided by 10. And so whenever we have the sine of B like we do here, then in order to get B by itself, that's when we're going to have to use the inverse button. So B is going to equal to the sine inverse of that same number, which I've now written 3 times. That's okay. And punching that into the calculator, we are going to get an answer, and that answer is going to be 43.6 degrees. Now, the fact that you got an answer when you type that into the calculator tells you that there is at least one triangle. So I'm going to now put this as B sub 1 to indicate that this is for the first triangle, B sub 1. And I'm going to finish solving this first triangle before I determine if there's another triangle in this problem. So now for capital B1, I know that that's 43.6. I can now find capital C1. And so capital C1 is going to be 180 minus 50 minus 43.6. And my suggestion to you is to not round this 43.6 until the end. So in your calculator, you would want to go back up and use the unrounded version of that number right there, and then round after you're done with that. And so if you do that, you're going to get 86.4 degrees for capital C1. And now we just need to find little c1. And so little c1 is going to be found by taking my given ratio, which will be 10 divided by sine of 50, and setting that equal to the little c1 ratio, which is little c1 divided by sine of 86.4. And again, I would not round 86.4. I would keep that number around, no pun intended, until the end and then round at the end. So 10 sine of 86.4, I'm just cross multiplying here, is going to equal to c1 times the sine of 50. And then dividing both sides by the sine of 50 is going to give you C1. Little c1 is equal to 13.0, and that finishes the solving of triangle 1. Okay, now over here in this little space, I've got some room to try and see if there is a second triangle. And so here is how we determine if there is a second triangle. We need to go back to this step right here when we got little b1 and see if there's going to be a capital B2. So if there was, and this is what we're going to do on every single problem when we check to see if there is another triangle, we're going to take that angle that we found first. So this was the first step. Whenever we found the first triangle, that was the first step. We're going to come over here and we're going to basically try to repeat this, but B2 is going to equal to 180 minus B sub 1. And so that means we're going to have B sub 2 is equal to 180, subtract 43.6, which would equal to 136.5. 0.4. Now, if that were possible, then what would have to happen is that 136.4 plus the given angle in the problem. So the given angle in the problem was 50. That is going to equal to 186.4 whenever you just add those numbers together. Okay, well, if this is B2 and this is A2, and those already add up to a number that's larger than 180, there cannot be a second triangle. Because remember, in triangles, the angles have to add up to 180 degrees. And if two of the angles already add up to more than 180, there cannot be a second triangle. So there is no second triangle for this particular problem. But there is one triangle, and we went ahead and solved for it. We got our capital B1 here, our C1 was here, and our little c1 was here, and that went along with the three pieces of given information that were given in part A. Okay, in letter B, we're again given side-side angle. We are given the A ratio here. So we have A is 4, little a is 4, and capital A is 50. So I'm going to have 4 over the sine of 50. And I'm going to set that equal to the B ratio, which is going to be little 6. Little b, I guess I should say, divided by the sine of capital B. Okay, go ahead and cross multiply here. So 4 sine of capital B is going to equal to 6 sine of 50. And divide both sides by 4 so that we get sine of B is equal to 6 sine of 50 divided by 4. And once again, using the inverse button on our calculator, sine inverse of 6 sine of 50 divided by 4. And when you punch this into the calculator in degree mode, what you end up getting is an error. It'll tell you that there's a domain error. And so what that means is that there is no triangle possible for this given set of information. So if you set everything up, you punch it in the calculator, and it immediately gives you an error, then that means there is no triangle. You would just put that answer and move on with your life. And so that's obviously one that we consider to be pretty easy because there aren't any triangles, and so there's nothing to solve for. Okay, in letter C, we are once again given side-side angle. And so we're going to set this up using the law of sines, trying to determine how many triangles there are and solving all of the triangles that possibly exist. So if I notice here, I've got the B ratio, and so I'm going to go ahead and set that up. 5 divided by the sine of capital B, which is 20, and I'm going to set that equal to the C ratio, which is going to be little c, which is 7, divided by the sine of capital C, which I don't know yet, and that's what I'm going to be trying to solve for. So 5 sine of capital C, just cross multiplying, is going to equal to 7 times the sine of 20, and then dividing both sides by 5 will give me sine of C is equal to 7 sine of 20 divided by 5, and so C is going to equal to sine inverse of 7 sine of 20 divided by 5. And so when I put that into the calculator, making sure that I'm in degree mode, I'm going to end up with a rounded answer of 28.6 degrees. And so the fact that I did not get an error there tells me that there's going to be at least one triangle, which means I'm now going to call that capital C sub 1 to indicate that it's for the first triangle. And I'm going to go ahead and continue solving that first triangle, which means I'm going to find my missing angle, which is angle capital A1, which is going to be done by subtracting the two angles that I have in the first triangle from 180. So 180 minus the unrounded version of 28.6 minus 20. And so punching that into the calculator is going to give you 131.4 if you round to the nearest tenth. Okay, so this would be step 2 for the first triangle. This would have been step 1 over here, and then step 3 for the second triangle would be to find side small a1, and that again is going to be using that given ratio from the first step. So 5 over the sine of 20 is going to equal to little a1 divided by the sine of capital A1. And again, try to use that unrounded version if you can by just going up and grabbing it in your calculator screen or storing it in a variable if you know how to do that. And so now I'm going to cross multiply. 5 sine of 131.4 is equal to little a1 times the sine of 20. And to get a1 by itself, we're going to divide by sine of 20 on both sides. So little a sub 1 is going to equal to, when you punch that into the calculator, round to the nearest tenth, 11.0. Okay, and that tells me the first triangle, but it does not tell me yet if there is a second triangle. And so now I'm going to try to determine if there is a second triangle by looking at the angle that I found first, which is this C1 right here. So if there was a C2, then it would equal to 180 minus that 28.6 number, which is equal to, when you punch it into the calculator, 151.4. Now, if there is a second triangle, then when I add that to the given angle in this problem, which is way back up here, it is 20 degrees. B sub 1 was 20 degrees. Well, B sub 2 would also be 20 degrees if there is a second triangle. And when you add those together, what you get is 171.4, which you can clearly see is smaller than 180 degrees. And so because this number right here, by taking this C2 and adding it to my B sub 2, which was given in the problem right here, because I got a number that was less than 180, that means there is going to be a second triangle, and C sub 2 is going to equal to that 151.4 degrees. Okay, and so since there is a second triangle, that means I can solve for the remainder of this second triangle. And so if you kind of follow what you did back up here, this was the second step. So now we're going to find A sub 2, which is going to be found by taking 180 and subtracting from B sub 2, which is 20, and C sub 2, which is 151.4. And so that is going to give me an answer of 8.6 degrees. So I'm just going to come down here and write A sub 2 is 8.6 degrees. And so this was step 2 for the second triangle. This was step 1 to figure out if there even was a second triangle. And so now step 3 for that third triangle is to now find side little a2 by using the given ratio. And the given ratio, again, is 5 over the sine of 20. And that's going to equal to little a sub 2 divided by sine of capital A sub 2, which is 8.6. And so if we cross multiply and divide, we're going to end up with 5 sine of 8.6 divided by the sine of 20. And so that is going to give you an answer rounded to the nearest tenth of 2.2. Okay, so 2 triangles on that problem. And really, I want to reiterate that whenever there are 2 triangles, this information that was given applies to both triangles. So that's why I was able to use that B ratio again down here for that second triangle, is because that given information is going to apply to both triangles. What's going to be different, sorry, there's a plane taking off overhead. Hopefully that doesn't throw you off too much. The second triangle is going to, you're going to find this information that was not given for that second triangle. Okay, we'll finish the day by talking about 3 word problems. So in example 6, we're given a really nice figure here. It says to find the length of the span of a proposed ski lift from a point A, which is here, until a point B. And that's what we're going to be finding in this problem. So you can call it X, or you could call it little c if you wanted to. That might actually be better since it's across from angle capital C, just to call it little c. Here's what it tells us. A survey measures the angle DAB. So DAB is here. They measure it to be 25 degrees, which they clearly show us is right there. And then walks off a distance of 1,000 feet to C, which measures angle ABC to be 15 degrees. or ACB, I guess I should say, to be 15 degrees. What is the distance from A to B? Okay, well, there's a couple of things that we can do here. The first thing is we can find angle capital A right here, because I know that this entire thing, let me actually erase this so I can start from scratch. I know that this is going to equal to 180. So if I know that this part right here, which I'll do in blue, is 25, then that means this red part that remains is going to have to be 180 minus 25, which is going to give us 155 degrees. Okay, and remember, we're trying to find side C right here. Okay, well, we have angle capital C. Angle capital C is 15. We have side L here. And so now what we have is we have angle. Let me use my laser pointer here. We have this angle right here, this side right here, this angle right here. And so that's angle side angle, which means we're going to use the law of sines. Okay, so we have angle capital A. We have angle capital C. That means we could also find angle capital B by subtracting from 180. So 180 minus 25 minus 155 is going to give us, I'm sorry, 25 is not correct. This should be 15, which was our other angle, right? So minus 15. Looking at the angles inside of the triangle, my fault, that's going to be 10 degrees. Okay, so this angle right up here inside of the triangle is going to be 10 degrees. And now I have a ratio. Notice that I have this angle capital B, and I also have the side opposite of angle B, which is L, and they told me that L is 1,000 feet. And so now I have a ratio. 1,000 divided by the sine of the angle across from 1,000, which is 10. And I'm going to set that equal to the ratio of the side that I'm trying to find. And so since I'm trying to find angle C, or side C, I'm going to set that equal to the C ratio, which is going to be C over the sine of capital C, which is 15 degrees. Okay, cross multiply and divide, and what you'll end up with, rounding to the nearest tenth, is 1,490.5 feet. Okay, on example 7, there's a couple of different ways we can do example 7. I'm going to do one of them and let you guys maybe try to figure out how to do the other way, but here's how I am going to do number 7 in this case. The first thing I'm going to do is I'm going to figure out what this top angle of this triangle is, of the big triangle, and the reason I'm able to do that is because it tells me that angle A is 20 and angle B is 30, and I know that every angle inside of the big triangle is going to have to add up to 180 degrees. So the first thing I'm going to start with is angle capital Z, as in zebra, is going to be 180 minus 20 minus 30, and that's going to end up giving me 130 degrees. And really the reason I wanted to do that is because I have side L down here. It tells me that this L is 1,000, and so now in this triangle I have a ratio. I have the Z, as in zebra, ratio, which is 1,000 divided by the sine of 130. Okay, so what that is going to tell me then, in this case, is that this is going to equal to, and here's where you have the option. You can either set this equal to the A ratio or the B ratio. It does not really matter in this case. You're going to end up getting the exact same thing. I'm going to go ahead and set it equal to the B ratio, which means I'm going to find side B here using angle B of 30. And so B divided by the sine of 30 is what I'm going to do, but you could just as easily have set that equal to the A ratio and found side A, and it wouldn't really matter. And if you do this, cross multiply and divide, what you're going to get is that side B is equal to 652.7, etc. And I'm not going to round that answer because that's not the final answer. Okay, but now I know that 652.7 is what this side right here is. And so now, if you look at just this left-hand triangle here, just this triangle on the left, here's what we know. We know that this angle is 20. We know what this side is. We know that it's 652.7, and we're trying to find the height, which from this angle of 20 is the opposite side of that angle 20. And so now we're actually going to use SOHCAHTOA because that triangle that we're looking at is a right triangle. So what we're going to have is sine of 20 is equal to the opposite side, which is h, which is what we're trying to find. Okay, how high is the airplane, right? So we were looking for the height, divided by the hypotenuse, which is 652.7, and I'm not going to round that number. I'm going to leave it in my calculator as it is, and so that's going to allow me to solve for h, which is going to be 652.7, etc., multiplied by the sine of 20, and punching that into the calculator is going to give you your answer of 223.2 feet. Okay, finally, example 8. A famous leaning tower was originally 182.5 feet high. So this tower, as you can see here, 182.5 feet high. At a distance of 127 feet from the base of a tower, the angle of elevation to the top of the tower is found to be 56 degrees. So you can see they have given you a really nice picture here to basically illustrate what they're trying to say. Find angle RPQ indicated in the figure. So here's RPQ. So what they're telling you to find is this angle right here. And then also find the perpendicular distance from R to PQ, which we'll do second after we do the angle RPQ. So what are we given here? We're given side, angle. And so because we're given side, angle, that means we're going to use the law of sines here. And what I've been given is I have been given this ratio right here involving 182.5 and 56. Okay, so I'm going to set up that ratio. The side is 182.5 divided by the sine of the angle, which is 56. And I'm going to set that equal to the only other ratio that I can set it up to, which is 127 divided by the sine of the opposite angle to that, which is r. So this is going to be 127 divided by the sine of r. And so cross multiplying and dividing is going to give me r is equal to sine inverse of 127 times the sine of 56 divided by 182.5. And punching that into the calculator in degree mode is going to give you 35.2 degrees. And so this angle right here is going to be 135.2 degrees. Now that obviously is not the angle that we were searching for, but because we now have two of the angles in a triangle, we can find the third one, angle P, by subtracting from 180. So 180 minus 35.2, subtracting the given angle, which was 56, and that is going to give us 88.8 degrees when rounded to the nearest tenth. Okay, so that is how to find angle RPQ that's indicated in the figure. You've got to find angle R here first, and then subtract that angle minus the given angle of 56 from 180 in order to find angle P. Okay, so I'm going to give you a second to write all that down, and then I'm going to need to erase this so that we can do the second part of this question, which is to find the perpendicular distance from R to PQ. And so hopefully that's enough time for you to have written all of that down on example 8. And now I'm going to erase this and work the second part of this, which is to find the perpendicular distance from R to PQ, which is going to be this right here. And so I'm going to call this H. And if you will just look at the left-hand side of this, this is going to give us a right angle right here. Okay, so this is a right triangle. We have the hypotenuse of this. We also have this angle right here, which we just found in the first part of this question to be 88.8 degrees. And so we're going to use SOHCAHTOA since this is a right triangle. And so this H is the opposite side. This 182.5 is the hypotenuse. And so we are going to use sine of 88.8 is equal to the opposite side, which is h, divided by the hypotenuse, which is 182.5. And so therefore h is going to equal to, when I multiply both sides by 182.5, 182.5 times the sine of 88.8. And punching that into the calculator, rounding to the nearest tenth, is going to give you actually 182.5 feet, which is the same answer, not quite the same answer because it's rounded, but when you round it, it ends up looking like the same value as that side right there. That's sort of a coincidence, not necessarily going to happen all the time, but just because of the rounding, that's what ends up happening here. Okay, that'll do it for Law of Sines in section 7.2. You guys feel free to let me know if you have any questions.